In this presentation, we are going to look at Markov chains. And children at a school are given weekly grade sheets in which their efforts are graded poor at 4 levels: poor, satisfactory, good, and excellent. Okay. Now, subject to a certain a certain maximum level of excellent and a certain minimum level of poor, we're giving the following pieces of information. Okay. So the 20% chance of moving up, 20% chance of moving down 1 level, okay? A 10% chance of moving up 2 levels and a 10% chance of moving down 2 levels. And it's not possible to move up or down 3 levels in a single week. Okay, now this actually is all the information that we have to go on here, okay? But we're additionally told this: maximum and minimum levels of poor. Okay. So let's just sort of think about this for a second. If I'm at a certain state, I could go, so this is our default state here, okay? And I can go up 1, plus 1. I can go up 2, plus 2. I can go down 1, minus 1. And I can go down 2. Okay. And the probabilities are 20%. Sorry, 10% for that one, 0.1, 0.2, 0.2, and 0.1. Okay. Now, but what happens if we start off at satisfactory? Okay, so let's just say we're starting off satisfactory. Well, if we go up 1 level, we go up to good. And if we go up 2 levels, we go up to excellent. If we go down 1 level, we go down to poor. But what happens if we go down 2 levels? This is the question. So here is what we will suppose here, that if you go down 2 levels, there is a minimum level of poor, okay? So what happens here is you're still classified as poor. And that's how we will approach this question. Now, let's just say, for argument's sake, we are starting off poor. And we go down 1 level, but we still will be classified as poor. And if we go down 2 levels, we'll be still classified as poor. Okay, so there are actually 3 possible ways you can be classified, or 3 states in this sort of sequence that will end up having us classified as poor. Okay, so this is how we will approach this question. Okay. The next stage up will be satisfactory, and then good. Okay, and it's not possible to go up to excellent. So 0 to go up to excellent. Okay, so that's how we'll approach this. Essentially, if you can go up or down by 1 or 2 levels, but what do you get classified if you hit that minimum value, that minimum threshold? We'll actually just quickly sort of discuss what happens if you're starting at excellent. Okay, so if you're starting at excellent and you go up a level, you're still excellent. If you go up 2 levels, you're still excellent. If you go down 1 level, you are good, and if you go down 2 levels, you're satisfactory. But it's not possible to go down 3 levels, so you can't go from excellent to poor in 1 week. Okay, so that's really the rationale of what we're doing here. Okay, so that actually takes a lot of thought. So just to sort of echoing what I've said before, that if you go up 1 level, if you're starting at poor and you go up 1 level, there's a 20% chance of that, 0.2. So P to S is a probability of 0.2. P to G is a probability of 0.1. P to E is impossible, so we have a probability of 0 there. But to remain at P when you're at P is 0.7. Okay, that's a combination of going down 2 levels to going down 1 level and just staying the same, and essentially that is so the joint probability, or the combined probability of that, is 0.7. Okay. Now, likewise, if you're starting at S, the probability of going up to G is 20%, up 1 level, The probability of going from S to E is 10%, which is 2 levels. So the probability of going down 1 level or down 2 levels will both end you up as poor, classified as poor. So that's a combined probability of 0.3. So there's a probability of 0.4 of a satisfactory student being satisfactory next week. Okay, and we work the whole way through that like that. So essentially what we do is just add up all of these probabilities if we hit those upper and lower bounds. Good and excellent are sort of the mirror images of poor and satisfactory in terms of how we write out the probabilities. So that's our transition matrix. So there it is there. And we just call that M. Okay, we'll just call that M. So the next question is, children are graded on Friday afternoon each week. On the Friday of the first week of the school year, there's little evidence on which to base an assessment, so all children are graded satisfactory at the end of week 1. Calculate the probability distribution of the process after the grading on the 3rd week. Okay, so let's just be very clear about this. This is week 1, and this is Friday, and everyone is satisfactory here. Okay, at the end of week 2, we have to figure that out. We actually don't have to figure that out. We have to figure this out here and specifically. Okay, so this is week 3, the end of week 3, and this is 2 transitions. Okay, so there's 2 transitions there. So what we're going to do here is use the transition matrix, the square of the transition matrix. And our initial probability distribution is, they're all classified as satisfactory, okay? All children are classified as satisfactory. So the probability distribution there is 0, 1, 0, and 0, okay? So 100% of the students are rated satisfactory at this point here, okay? So what is the distribution here at the end of week 3? So essentially what we're going to do here is to calculate it as we do this here. This is our distribution for at the end of week 1. This is the transition matrix for the first week and then the second week. So essentially what we do is we multiply everything out, okay, m squared. So essentially this is a big long matrix calculation here, and it'll take a while to do it. But I'll just do one here briefly. So the top column, or the top corner cell, will be the top row multiplied by the first column, 0.7 times 0.7, 0.2 times 0.3, 0.1 times 0.1. Add all of those up together and you get 0.56. Now essentially what you have to do is take a bit of time to go through the whole thing there. What should happen at the end of this calculation, something you double check, is that all the rows still add up to 1. Okay? Now, so what we're going to do is multiply m squared here by 0.10100. Okay? Now, essentially what that does in essence is actually just picks out this row here. Okay? And that is the distribution we will get. So 35% of children will be graded poor, 27% of the children will be graded satisfactory, 21% will be graded good, and 17% will be graded excellent. Okay. Now, this is obviously a very weird school and a very weird way of doing things, but that's beside the point. It's how we study this using a Markov chain is what we're interested in here. So we leave it there.